Thanks. Hello, everyone. It's really a pleasure to be here with you. I would like to talk a bit about signals and taking a peek into it. Just a few words about me, other than I'm being old. If you want to have some fun and you want to consider how to check for a positive integer in JavaScript, you can take a look at this comment. Actually, I think it's quite entertaining. Other than that, I don't think there's much of my work in the internet, so I just think this one. But yeah, please take a look, have fun with it. And question to you: who is already familiar with signals? We have around 6-7 people. Okay, not bad. Okay, who is familiar thanks to Angular? Okay, and SolidJS? Okay, some other options? Okay, there's one. Awesome, thank you. Okay, so just to set up the baseline, I'm not going to talk and touch any of the framework implementation. I would like to talk about the signals proposal for the JavaScript. So this is a bit different when it comes to some API. So also regarding it will be clear a bit later, but first of all, there is a polyfill that is already provided as a part of the proposal that is nice to check. And second, I think the highlight is quite important, that the proposal is not aiming to target the API for everyday framework developers. It's really targeting the API that is lying beneath it, that is used by framework developers. Okay, so when I heard about signals, I tend to compare to what I already know, so promises and RxJS. And starting from that, what are we getting? Like from the promise, single value. I don't think anyone expects to get the second, right? RxJS, stream of events. So why I call it events, still not the value? It's easy to imagine that we get, I don't know, for example, player events, right? But then we can combine another stream of events like user interaction. So we have two different types of events that are intertwined. So there is not a single type. Well, it can be, but there are other options that you don't have it. And what is also worth mentioning is that on promise, we are getting single value, and we always can access it, right? We can always attach callback and do something with it. With RxJS, by default, that's not an option. Of course, we can have behavior subject that works. So, and we can access if we really want some previous events, right? With the signals, it's a bit different in a way that we have a state. And by state, there's a stream of values, but they are of the same time. We don't expect that we will be giving different type of objects. This is a state, this is something that we want to have consistent. So this is what signals is, why signals are different in that matter. So when we have that value, what can we do with? Right, on the promise, we can use promise chain. use another async, and do something, use whatever JS function we want. On a RxJS, crazy amount of operators. We can combine, transform events in a crazy amount of ways. And in the signals, we have computed. So when it comes to computed, we are basically getting the state, and we can use pure function to do something with that state. Maybe use two signals and combine values from two signals, but we are expecting to have pure function overall. And we don't expect to have access to the old values in general. So after that, what's the cleanup? So the cleanup is that promise garbage collector, right? Nothing. It's applied to all, of course. In RxJS, that's for me was very, very awesome mechanism that when we are unsubscribing from the stream, we have destructors, right? We can destroy all the events that were attached. And frankly, this is quite powerful because Rx can have multiples operation on top of each other, and it's not so easy to track when to destroy it. So when we lost the last subscriber, we get rid of the Rx. So what about the signals? It's not that easy to answer. What I can put is that signals are lazy when it comes that if someone is not asking for it, it's not going to evaluate. And let me address this a bit later in the presentation. So let's get to the example. And okay, that's the example, and it's really quite simple, right? We have two counter implementation, one in JavaScript, one in JS using signals. So we have a counter, we have a function to set it, we have a function to is even. By the way, who likes that implementation of is even? Like that's my personal preferences, but we are using operators that it's not so that easy to read for most of the developers. Okay, so then when it comes to signals, we have dedicated API, also very simple. We create the signal, we set the initial state, and we are setting some computed values, right? The effect, you can forget about it, basically, at this point, and you get the counter set. The effect will get one of the computed signals and update DOM fragment, right? Well, element X, to be specific. So how signals are working? They are represent a cell of data, right? This is part of actual quote from the specification. And they can be set manually, they can be computed, but basically that's it. And what's crazy important about signals is that they are automatically tracking which other signals are read during their evaluation. So basically, what I mentioned at the beginning, we have a graph behind the signals. So when we have signals, we have a graph that is tracking, is the value being read? Do we want to really calculate the value? And what are the dependencies? What are the other signals that are looking for that new value? So after that, it's easy to get that, okay, we have a graph, we have a dependencies. Like, it's really not brainer to cache, to minimize the data, to make it a bit more optimal. And yeah, to track if we really need to keep the values, right? Like garbage collector and graph coloring attempt to get rid of unused values that's kind of go to. So this one maybe not named the best. However, I wanted to show that every node on in the signal graphs, in the signals, internally there are information that we have a dirty state, we have a computing, we have clean, we have checked. So those are all there, not visible to the user, not visible through the regular API, but it's there. Okay, so I mentioned that the API is crazy simple. And like, how much simpler can it get? Like, constructor gets set for the signals you can set. For computer, that of course you cannot use set, right? So like crazy simple. And that's the reason why this is not audience for the proposal. It's mostly about the subtle, about how to interact with the graph, how to interact from the framework perspective, and make best of that graph, because we have actually one-way data flow at this point. To be honest, very optimal, very designed to be optimal, designed to be lazy, designed to track dependencies, like kind of a dream for a framework developer. At least I'm impressed. Like, if I would implement framework, I want this. So, sorry, went ahead a bit. Another class, basically part of the subtle, and addressing dependencies. This is the dependencies. And when it comes to API, that's it. That's the whole Signals API. It's not that simple if you are looking into polyfills, because there are a lot of tricks underneath. But when it comes to API, that's it. So this is important in terms that, okay, now the fun begins when you want to implement effects, right? So my first thought was, okay, how does combine with the rest of framework? And proposal is not going to answer this. It's like for framework developers to interact with signals, to implement effects to the liking due to difference in scheduling, different approach to how to render and when to render. This is implementation of effects that was mentioned in the proposal, just to show something very, very simple. I don't think I will get in details. Okay, so there are some questions that were at the very end that I really enjoy, because they were like starting to get my mind working, right? So can we build signals even, can built-in signals even be used by frameworks given their tight integration with rendering and ownership? And I think it's a really good question. And yes, that's the idea behind the signals. That's the whole concept, that we want to make state independent and decouple from the framework. And of course, framework will some heavy lifting, but it also is a way to have a lot of room to optimization and to push approach that given framework is taking. However, the data part, it can be, hopefully, can be abstracted in Signals. So next one, do I have to tear down signals related to a widget when that widget is destroyed? What is the API for that? I mentioned that there is not so easy to answer how signals are destroyed. And that's because they are asking, once again, framework developers to unwatch, to make sure that when the signal is not needed, the signal is informed about it and can do its magic and can propagate. So once again, that's the reason. I think that my favorite question from the proposal: are signal push based or pull based? So we mentioned that they are lazy evaluated, right? You cannot have like push based if you have something lazy evaluated. Okay, so that's the answer. No, not really, because signals will be notified that, okay, someone is watching you. You want to, as a part, sorry, during the get phase of the value of the signal, you can track the reference. So then signal can notify the effect to read, and the effect can trigger and read from that signal. So on one hand, it's only evaluated when you read it. On the other hand, signals are notifying framework to run effect, and by that they are most likely will be read, right? Okay. What does it mean for signals to be loosey? That's kind of easy. Like, it's a state. So if you don't read it at a given moment and it will change, it will change. That's it, right? You don't have the previous value. Like in the RX, probably you could design for it. In the signals, no, you are interested in the state, right? So I don't know how much time we have. Okay, we have some. So I was pretty impressed overall about how many framework is trying to implement signals. Like, you can choose your favorite framework, you can connect with Signal in the Google search, and most likely they are already either implemented or there are some approaches how to make them to work together. So from that perspective, it's really awesome and amazing that there are that much of effort going on. So what are the benefits also for the standardization? Sorry. I think I switched the slide. Okay. Benefits for the standardization. So there are a few. One, of course, performance, but this is like important a bit, like every framework wants to be performant, but it was mentioned as a second. The first one is to be able to have a common approach through all the frameworks, to abstract really state from the rendering, from the effects, and by doing that, really have one approach. The other piece that can be really nice is that if we have a standard for signals, there is option for the DevTools to be built around, right? Like, I don't know, probably some of you were debugging RxJS. I don't know who thinks it's a pleasure to go through all those streams, especially when you have multiples, combining them and tweaking. Of course, there's a nice plugin for it, and hopefully with Signals we will get similar options, especially that they are introducing API for introspection already. So that's one of the possibilities. Another mention was that there are some potential, right, to introduce this being way closer to HTML and to really do those fine, great updates. But we'll see. I think that's the long term. Okay, that will be all that I presented. So let's hear from you.
Maybe you mentioned it, but what do you think are like most important practical applications of this technology?
Frameworks, like straightforward answer, this framework. And it's, if you remember, like, well, maybe you work with Angular, like two-way data binding really was a nightmare there was a lot of events going up and down if you didn't optimize for that. You needed to have in mind that there's that one-way data flow. And this is what Signal is targeting, one-way data flow with computed values that can be lazy evaluated. So there is a optimization on the state, and it's really enables to get the smaller updates overall because you have that clarity on the state. I hope I answered your question. Thanks.
Yep, thank you for the presentation. I thought I knew what signals are, but now I know for sure. And the question is, when we have the virtual DOM in React replaced with signals and we have adequate re-rendering of the whole DOM?
So I don't think that after that presentation I know more or less about the signals after preparing, as always. But addressing your question, I don't think React will get rid of the virtual DOM. I think the benefit will be that the diffs will be much smaller, and that will be impacting the performance. However, when we are looking into Angular, they are getting rid of Zone.js because of signals. So that's, I think, a very, very big change in the framework.
With signals being implemented in most of the modern frameworks, except for React, of course, do you have perhaps your favorite API in one of the major frameworks, like Svelte, Solid, Angular? What's the best? Which one has the best signals?
No, that would be deep dive. I didn't do that, to be frank. I'm looking forward to see how the different frameworks are implementing it, but to be honest, that's also a crazy amount of research. So not soon, I think. But one day I hope I will be able to answer it. Thanks for the question.
Thank you very much for your pace, because I was able to keep up. Let's say, my question is, let's say you need to, signals depend on the fact that you always use only signals. Otherwise, you can't keep track of the dependencies, right?
Well, the dependencies are tracked like signal to signal, right? That's the graph structure.
And what happens if, my question is related, just to give you a warm-up, what is happening if we are not using, we are using some external library which is not calling signals by itself. So let's say this is a legacy code.
Mm-hmm.
And my question is, do you think we can cover such libraries, for example, by we can like we can be still able to use such a libraries, and how you would do it? Because the only way I was able to come up with a solution to this is introducing proxy objects or listeners for setters and getters.
Yeah, I think that's the way to go, right? You need to be able to transform those changes in the state to signal at some point, right? And for that, you need some kind of listener. You need to be able to track those changes. So however you implement it, you need to still make signal out of it. Otherwise, you are introducing state that is not tracked and multitude of errors because that state is out of the graph. Thanks for the question.
Do we have any more questions from the room? So I have one question, obviously. So let's say that a developer was working in a different framework that was not supporting Signals yet, and whether they have their own implementation or they're using the future baked-in Signals implementation from the platform. And basically, the developer needs to learn the paradigm, the approach, whatever we call it. Despite the fact that the API is rather thin, what would you say are the biggest challenges in terms of learning how to think in Signals?
If you context that into framework that already is implementing Signals, I don't see much. The API is really thin for the client, right? And it's on the framework to do the heavy lifting, to do the tracking, to do all the control about the destruction of the signals. So from that perspective, I don't see much. The one thing is that, okay, the API is not unified, so I'm switching from one framework to another, and the API of Signals may be different. And maybe there is one thing that is worth mentioning, that because the API is not unified, especially on the inside level, on the sub on how to track changes and communicate, there will most likely be issues when you want to have two different single implementation work together. Even the external API is the same, but internally, most likely they will not work together.
Thank you. So thank you very much for the talk.